All right, fellas, in this test, we're just going to do a vertical upward so we can get a better look at this flame profile. The wind's kind of messing with it. I want you to get a good look at this and so you can see that it does look like the burner in the video that you sent me. So let's take a look at this again. All right, this thing isn't made to run in this direction based on the way these lines are connected. We're going to get some liquid showering down in here if this doesn't get hot enough. Okay, and let's go for a little walk here. I hope I'm pronouncing that right. I don't know for sure, but this is what we came up with. I initially start the burner with the valve fairly cracked open at all. It's probably on 25% setting right here. So the initial fuel consumption rating that I did is going to be off by just a little bit. So we're going to have to do it again. But nonetheless, we're going to be derating it. So the rating that I come up with here, which was 2.7 million BTUs, is actually more than that. So I'm actually doing us a bit of a advantage here, because when I do the test again, it's going to be a lot higher output than this. So you can see here where I crack the valve open all the way, and what I do to calculate the fuel consumption or the power output of one of these devices is I time the experiment with the stopwatch on the GoPro. And that propane tank that you see that's been inverted has been weighed prior to the test. And subsequent to testing, the tank will be then weighed again, which come out to 8.8 pounds. So we know there are 3,600 seconds in an hour. If our runtime was 249 seconds, we divide that by that 3,600 seconds by 249, and we come up with 14.5 or 14.4 or something like that. We then multiply that 14.4 times the 8.8 pounds that we burned, and that tells us how much we would burn in an hour, which comes out to 127.2 pounds an hour. And if you multiply that figure by 548 BTUs per pound, you come up with 2.7 million BTUs an hour. And that is right around 803 kilowatts, or 1,077 horsepower for you horsepower guys out there. That just kind of helps us wrap our head around how much power is actually here. Now, if you were to hook this burner up to a steam engine, you probably wouldn't get 1,000 horsepower because of the efficiency and all of that. But you could get close to 800.
For about 5 minutes or so.
Thermally, we're looking at 1,000 some horsepower
reading.
Thermodynamically speaking. I don't think this flame is as big as we need it to be, Nan. The video you sent me shows what appears to be about the size of a man, a good 6 foot tall man. So we're going to do this test again without having this thing on full throttle. You can see there we're not really losing any bottle pressure. It'll run like this continuously. Of course, you guys will be hooked up to propane tanks the size of a truck, so it's going to be a bit different. But this is just kind of showing you what the liquid propane system can do with the vaporizer coil. Wow, it's freaking shooting snow all over the place there. So, definitely some ice buildup in there. But in the hot conditions this thing's going in, that ain't gonna happen. Okay, and these flames appear to be about 9 foot tall maximum. I could be wrong, but I think we were way bigger than this personally. So I'm going to turn the thing down and re-rate it.